There are discoveries that shake astronomy, discoveries that confuse astronomers. And then there are discoveries that crack open the very floor beneath physics itself, the kind of discoveries that force Nobel Prize winners to fall silent during interviews, that make cosmologists close their laptops and quietly whisper, "This doesn't make sense." They make even the most confident defenders of the Big Bang pause mid-sentence, because the data before them simply should not exist. The James Webb Space Telescope has now delivered exactly that kind of discovery. It has uncovered something so profoundly contradictory, so violently incompatible with our current theories of galaxy formation, cosmic evolution, and the origin of matter itself, that scientists are being forced to admit, reluctantly, nervously, and in some cases publicly, that something may be fundamentally wrong with the way we understand the early universe. Webb looked deeper than any instrument in human history, beyond the cosmic dark ages into the era where the first faint glimmers of starlight were expected to appear. Instead of finding tiny, primitive galaxies slowly emerging from hydrogen clouds, it found monsters, hyperbright, perfectly structured, impossibly massive objects that should not have existed for another billion years. These objects are not behaving like galaxies. They are not forming like galaxies, nor are they evolving like galaxies. In fact, they may not be galaxies at all. As image after image arrived, each one breaking another piece of the standard cosmological model, a quiet realization spread through the scientific community like a shockwave. James Webb had not simply revealed new objects, it had challenged the foundations of modern physics. It all began with a single object, a small yellow blur hidden within one of Webb's deep field images, barely noticeable among thousands of faint points of light. There was no reason to think it was extraordinary. Nothing about it immediately suggested a cosmic anomaly except for one stubborn detail that refused to be ignored. It was far too bright, not just slightly brighter than expected, but bright enough to violate every luminosity model we have for the early universe. At first, astronomers assumed the object was much closer than it appeared, believing it was simply a common error in estimating cosmic distances. But spectroscopy shattered that explanation almost instantly. The redshift was enormous, confirming that the distance was real. Suddenly, researchers found themselves looking at the most distant galaxy ever observed, existing when the universe was only 290 million years old. Yet it did not resemble a young galaxy. It was not primitive, chaotic, or small. Instead, it appeared structured, massive, and fully developed, a mature system existing in an era when only cosmic newborns should have existed. That was the moment quiet panic began spreading behind the scenes. If even a single fully formed galaxy existed at such an early time, then our understanding of the physics of the early universe would require serious revision. Within days, Webb revealed that this object was not unique. It was not a statistical fluke or a one-time anomaly. It was the first member of an entire population of objects that seemed to violate every rule in our cosmic playbook. James Webb's deep field observations were expected to provide a glimpse into the universe's infancy, faint, scattered points of light representing the earliest stages of galaxy formation. But when Webb turned its infrared vision towards some of the darkest regions of the cosmos, it did not find infancy. It found maturity, complexity, and intense activity. Thousands of unusual objects filled these images, and the more astronomers studied them, the more they realized they were not looking at ordinary early galaxies. These objects are too bright, too compact, too massive, and too well organized. They bear little resemblance to any known type of protogalaxy predicted by standard cosmology. Even more astonishing, they appear throughout the early universe rather than existing as isolated oddities. It is not one anomaly or two, but an entire population of cosmic structures that seemingly should not exist at that point in cosmic history. A recent study identified 87 candidate galaxies that appear to have formed between 200 and 400 million years after the Big Bang, a number so unexpectedly large that it challenges the predictions of the Lambda CDM model, the current foundation of modern cosmology. One of the study's authors openly admitted that even if only a small fraction of these objects prove to be genuine, scientists will need to rethink galaxy formation from the ground up. This is the uncomfortable implication of Webb's observations. Rather than revealing a universe growing gradually from tiny beginnings, the telescope appears to show a universe that skipped its opening chapters entirely, a universe whose distant edges already seem remarkably mature, one that evolved far faster than existing theories predict. It is a universe behaving as though the standard Big Bang timeline is either incomplete or missing something essential. As if these bright, massive early objects were not surprising enough, Webb uncovered something even more difficult to explain. In galaxies observed today, only about 10% of the available gas is typically converted into stars. That limit is so consistent and so deeply embedded in astrophysical theory that it is considered almost a universal law. Yet Webb has identified 3 early objects in which essentially all of the available gas appears to have been transformed into stars. Every atom, every molecule, every particle seems to have been converted. Under current theories of galaxy formation, this should be impossible. Galaxies require time for gas to cool, collapse under gravity, fragment into clouds, and undergo repeated cycles of star formation and inactivity. Webb's objects, however, appear to have formed through an entirely different process, one that has no place in modern astrophysical models. These mysterious objects are not behaving like galaxies as we understand them. They seem to represent something entirely different, something for which astronomers do not yet have an adequate name. Some researchers have quietly suggested that they may belong to an entirely unknown class of cosmic object, one that predates every theoretical model developed so far.